This is Trigonometry video lecture for section 1.2 on the rectangular coordinate system. Now, the rectangular coordinate system allows us to connect algebra and geometry by associating geometric shapes with algebraic equations. So, for example, every non-vertical straight line, which is a geometric concept, can be paired with an equation of the form y equals mx plus b, which is an algebraic concept. And m and b are real numbers. M stands for the slope of the line, b stands for its y-intercept. And x and y are variables that we associate with the axes of a coordinate system. Now, the rectangular or Cartesian coordinate system is shown below. Notice here we have the x-axis that runs horizontally. The y-axis runs vertically. And where the x and y-axis intersect is called the origin. The coordinates of the origin are 0, 0. Now the axes, the x and y axes, divide the plane into 4 quadrants. And these quadrants are numbered 1 through 4 in a counterclockwise direction. So if you look at the figure above, you can see that any point in quadrant 1's right here, any point there will have both coordinates that are positive, meaning both the x and y coordinate of a point that lives there is going to be positive. In quadrant 2, any point will have the form negative x coordinate, positive y coordinate. In quadrant 3, which is down here on the left, both the x and y coordinates will be negative for any point that lives there. And in quadrant 4, you could probably guess it's positive, negative. X is positive, y is negative. This is going to be useful, especially later on as we study trigonometric functions and their signs. Also, any point that's on the x-axis, so any point on this line here, on the x-axis, will have a y coordinate of 0, meaning it has no vertical displacement. And any point on the y-axis, so any point that lives here on the y-axis, will have an x coordinate of 0, meaning there's no horizontal displacement. Now, a very common formula that we're going to be working with is the distance formula. So if you want to compute the distance between any 2 points, and those 2 points we're going to refer to as x1, y1, x2, y2 in a rectangular coordinate system is given by the following formula. I'll rewrite it here. The distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Burn this in your brain, put this to memory. You're going to use it throughout the rest of your math career, however long that may be. Okay, so let's practice an application using the distance formula. Find the distance between the points -1, 5, and 2, 1. So what I always recommend is label the points. That's where most students tend to make mistakes, is plugging in the points incorrectly in the formula. So I'll call this first one x1, y1, the second one x2, y2. Doesn't matter which is which, just be consistent with the subscripts. And here we go. So the distance is going to equal, I'm just going to rewrite the formula from scratch. The more you write it, the quicker you'll put it to memory. So it's x2 minus x1 squared plus y2 minus y1 squared. I once had a student say the formula looks like a semi, and I can't unsee it now that they said it. I agree. All right, so we've got square root. x2 is 2 minus x1 is -1, and then we square this, plus y2 is 1 minus y1 is 5, and we square that. Now, 2 minus -1, that's 2 plus 1. So that's going to be positive 3 squared plus 1 minus 5, that's -4 squared. And then I'm just going to keep simplifying. So I have the square root of, this is going to give me 9 plus 16, which is the square root of 25. And this simplifies to 5. So the distance between those 2 points is 5 units. All right, good. As long as you remember the formula, you'll be in good shape. Now, let's look at circles. A circle, by definition, is the set of all points in the plane that are a fixed distance from a given fixed point. Now, the fixed distance is called the radius of the circle, and the fixed point is called the center. So those are the two key characteristics to uniquely identify any circle. If you're like, I need a positive ID on this circle, quick, you need the center and you need the radius. If we let r be greater than 0, be our radius, so we're going to let that little lowercase r stand for the radius, and then h and k represent the coordinates of the center. Remember, the center is fixed. And then x, y will stand for any of the points on the circle. There's going to be infinitely many of them. I'm going to show you how we come up with the equation for a circle. So we're going to apply the distance formula right now. I want to find the distance between any point on the circle and the center, hk. I'm going to rewrite the distance formula here. It's x2 minus x1 squared plus y2 minus y1 squared. And for x1, y1, and x2, y2, I'm going to use hk, the center, and xy, which represents any point on the circle. Well, I know the distance between those 2 points on the circle is going to equal r. I already know that. And so this is equal to the square root. I have x minus h squared plus y minus k squared. And then if I go ahead and square both sides to get rid of the radical, now I have the equation of the circle that we most commonly use, which is x minus h squared plus y minus k squared is equal to r squared. So when you're working with circles and you're asked to find their equation, this is the form that you want to put it in. Okay, so let's look at an application here. It says verify that these 2 points, rad 2 over 2, negative rad 2 over 2, and negative rad 3 over 2, negative 1/2, both lie on a circle of radius 1 centered at the origin. So first let's come up with the equation of the circle that they're describing here. They're telling me that the radius is 1, so r is 1, and it's centered at the origin. That means hk, the center, is at 0, 0, the origin. So the equation for this particular circle is going to be x minus 0, x minus h squared, plus y minus 0 squared equals 1 squared. Now I can clean this up a smidge. This is going to be x squared plus y squared equals 1. So this is the equation of the circle that they described to me. Now what I need to do is check that this point and this point lie on the circle. Well, what does it mean for a point to lie on the circle? That means it must satisfy the equation of that circle. So what I'm going to do is go ahead and plug in rad 2 over 2 for x and negative rad 2 over 2 for y. Confirm that I get a true statement, that it satisfies the equation, and then that will tell me that point lies on the circle. So I'll just start with that first point. Let's check rad 2 over 2 and negative rad 2 over 2. I'm going to plug it in, x squared plus y squared equals 1. So rad 2 over 2 squared plus negative rad 2 over 2 squared. Does that equal 1? Put a question mark until you verified, right? You don't want to say, oh, it equals 1 before you really know for sure. So rad 2 over 2 squared, if I square rad 2 in the numerator, it becomes 2. If I square the 2 in the denominator, it becomes 4. So in case you need a little refresher, this exponent distributes to the numerator and denominator. Plus, and then if I square negative rad 2 over 2, I'm going to get the same thing because when you square something that's negative, right, the two negatives will cancel out. So I get, again, 2 over 4. And 2 over 4 plus 2 over 4, that's 1/2 plus 1/2, or 4 over 4, which is 1. So yes. And then now I need to just check the other point, negative rad 3 over 2 and negative 1/2. Again, I'm going to plug in negative rad 3 over 2 for x and negative 1/2 for y. Why don't you pause the video and then try this on your own, see if you can confirm that this point will satisfy the equation. And then check back in. We'll work on it together in a minute. Did you pause it? I hope you did. Okay, so let's see. Negative rad 3 over 2 squared plus negative 1/2 squared. Does that equal 1? So if I square negative rad 3 over 2, remember the exponent distributes. So this is positive 3 over 4 plus positive 1 over 4. Yep, that's 4 over 4, which is 1. So both points lie on the equation of the circle, as we confirmed. Good, now moving on. Definition. An angle is said to be in standard position if its initial side is along the positive x-axis and its vertex is at the origin. So if you'll remember in the previous lesson, we talked about angles. And we said that angles, which we often refer to as theta, have a vertex, an initial side, and a terminal side. And we refer to them as being in standard position if this initial side is along the positive x-axis and if this vertex is placed at the origin. This is very important because most of the time when we work with angles in this course, they will be in standard position. So example 6 says, draw an angle of 45 degrees in standard position and find a point on the terminal side. Okay, here we go. So here's x, here's y. I'm going to draw an angle of 45 degrees in standard position. So here's where the vertex is going to be. This is the initial side of the angle. And I'm going to sweep out an angle of 45 degrees in the counterclockwise direction. You don't have to get your compass out, okay? As long as you label things, they don't need to be perfectly to scale. So I'm going to say, hello everyone, this is a 45-degree angle as I've drawn. Okay, so I took care of that part. Now the problem is asking me to find a point on the terminal side. So what they want me to do is find a point, any point that's on this line. Okay, and in order to do that, you need to know a very useful fact, and that is that this 45-degree line has a slope of 1. M is equal to 1. So if you remember the equation of a line, y equals mx plus b, m is equal to 1 when the angle that the terminal side makes with the positive x-axis is 45 degrees. Here I can see m is 1, b is 0, so the equation of this line is y equals x. This is a very special line, meaning the x and y coordinates are equal for any point on the line. So you pick a point, 0, 0, that's not on the terminal side. But this point, that's on the terminal side. 1, 1 would be on there. So would 2, 2. So would 3, 3. So would 4, 4. So would pi, pi. So would a million, comma, a million, whatever you want. Okay? So they only ask for 1. I'm just letting you know we can get however many we like because x and y coordinates are equal. 1/2, 1/2, 7/8, 7/8, etc., etc. That's something special about that 45-degree line. Okay? Good. Now some vocabulary that you're going to need to familiarize yourself with. So if an angle theta is in standard position and the terminal side of theta lies in quadrant 1, then we say theta lies in quadrant 1. So basically we characterize an angle and say where it lives based on where the terminal side is, if that makes sense. And we abbreviate that by saying theta is an element or belongs to quadrant 1. So if you haven't seen that notation before, it means is an element of or it belongs to. Now, if the terminal side of an angle in standard position lies along one of the axes, meaning you have either a 90-degree angle, that would go here, a 180-degree angle, 270, something like that, then it's called a quadrantal angle. Quadrantal. So for example, an angle of 90 degrees drawn in standard position would be a quadrantal angle because the terminal side would lie along the positive y-axis. Likewise, 270 degrees in standard position is also a quadrantal angle because the terminal side would lie along the negative y-axis. So 270 is here. That's a quadrantal angle. 90 is here. 180, again, quadrantal. 360. And negative as well, negative 90, negative 180, negative 270. We're going to talk about that in just a second. Now, two angles in standard position with the same terminal side, so this is the terminal side, are called coterminal angles. So if you notice here, these angles are coterminal because the first one's terminal side is in quadrant 1. It makes an angle of 60 degrees positive with the positive x-axis. The other angle arrives at the same terminal side in quadrant 1, but the direction that it sweeps out is clockwise, which means, remember, that it has a negative sign attached to it, so that it's negative 300 degrees. Notice the difference between these two angles. So if I were to subtract them, if I were to take 60 degrees minus negative 300 degrees, that's 60 plus 300, which is 360 degrees. So something to keep in mind about coterminal angles, they always differ by 360 degrees. Or it's multiple. So 720, negative 360, so on and so forth. Because basically you're just taking laps around, you're taking extra revolutions in order for the side, the terminal side, to be the same. So you can add or subtract 360 as many times as you want, and those angles will all be coterminal. Okay, so let's look at an example here. It says draw negative 90 degrees in standard position and then find two positive angles and two negative angles that are coterminal with it, with negative 90 degrees. So here we go. Here's the y-axis. Here's the x-axis. So first I'm going to draw negative 90 degrees in standard position. So I'm going to use the positive x-axis as my initial side, and negative 90 degrees would have its terminal side lying along the negative y-axis. Great. Now they want me to find two positive angles, I'll worry about the other part in a second, that are coterminal with negative 90. So positive angles would be swept out in the counterclockwise direction. So here's one angle, and that angle has measured 270 degrees. Now, how would I get one more? Well, I could go the same 270 and then go around one more time. So this angle is 270 plus 360 degrees, which is 630 degrees. So two positive angles that are coterminal with negative 90 are 270 degrees and 630 degrees. They only asked for 2, but if I needed more, I could just keep adding 360 as many times as my heart desires. All right, now I need 2 negative angles that are coterminal with negative 90 degrees. Okay, so let's clean this picture up. If I need negative angles, that means I need to still go in the same direction, so I need to go clockwise. So here's negative 90, just spin around one more time. So that would be negative 90 degrees and another negative 360 degrees, which is going to be negative 450 degrees. And then to get one more, you would just take that angle and add another negative 360, which would be negative 810 degrees. So I'll draw it for you. The last one, we're going to draw negative 450. So negative 450 would be here, and then keep going. One more. There's negative 810. Okay, you can see it gets messy as you keep swirling around. So 2 negative angles. If you're asked to do this, you don't have to draw every single angle. I just did it to help you understand. You can just add and subtract 360 if you get what's going on. I'm happy if you do. So negative 450 degrees, negative 810 degrees. Don't forget to put your degree sign, so important. And we're done. That's the final answer. So that concludes the lesson.